Welcome back to the Solid Principle series. My name is Darlington. Today we're diving into the open-close principle, or what's called the OCP. The OCP states that software entities like classes, modules, etc. should be open for extension but closed for modification. What does that mean exactly? Well, it means that you should be able to add new functionality without altering existing code. Why is that important, you may ask, right? So modifying code can introduce bugs and regressions. So by extending instead of modifying, we minimize the risk of breaking existing functionality. So let's illustrate this with an example. We'll jump right into the code here. So let's imagine we have a system that calculates the area of different shapes. Here we have an area calculator class. This class has a method called calculate area. It takes a shape in the form of an object, and depending on what that shape is, say for instance for rectangle we're just multiplying width times height and returning the value. For circle we're multiplying pi by radius and returning that as the area. So now let's imagine we wanted to add functionality to calculate the area of a triangle. In order to do that, we'd have to modify the calculate area method, thereby breaking the open-close principle. So let's look at how we'd have to do that. So we just have to add another else if block here. This would work, but again, as I said, this breaks the open-close principle. So let's look at a different approach that adheres to the open-close principle. We're going to make use of the strategy design pattern to achieve this. We'll start by introducing a new interface. We'll call this shape. And shape has a single method called calculate area. Now let's introduce a new class. We'll call that rectangle, and rectangle will implement shape. And because rectangle implements shape, it provides an implementation of calculate area. Let's introduce another class. We'll call it circle. Circle also implements shape. And again, circle provides its implementation of calculate area. Now let's add our new shape, which is triangle. Triangle also implements calculate area, and the calculate area just returns the value of half times base times height, which is the formula for calculating the area of a triangle. Okay, with that done, let's jump back into the calculate area class. So we'll need to make some changes here. Let's get rid of all this code and let's change the calculate area method to now take a shape. And we know that all our shapes have an implementation of the calculate area method. So all we need to do now is return shape.calculateArea. Now let's clean this up by removing all this redundant code. Let's have a look at the changes again. So we introduced a shape interface, and a shape interface has a single calculate area method. So any shape that implements the shape interface would have to provide a calculate area implementation. So now to add a new shape, we simply just need to create a new class that implements the shape interface. No need to touch the area calculator class. That's the open-close principle in action. It promotes flexibility and maintainability by allowing you to extend your code without modifying its core structure. This approach keeps our code open for extension and closed for modification. Please give this video a like if you found it helpful, and stay tuned for the next video where we'll explore the Liskov substitution principle. See you in the next one.